Anders asked me a couple of weeks ago
if
I could do something, present something, maybe a little about Git, but I think we covered Git a lot today. So I will talk about PPL or project organizations regarding code and code sharing between in a larger group. So I worked with LabVIEW since 2008. Was handed over a project by my team leader saying, do this, I did this, fix this, it doesn't work. Since then I've been CLD, an active CLD right now. And I do projects both in LabVIEW and testing. So we are talking about libraries and packed project libraries. So what is a LabVIEW library? LabVIEW library is a part of a collection of VIs and controls and classes. You can put whatever you like in your library. It forms an execution scope for the VIs, so they sit within that library. You can define properties like if it's a public VI or a private VI. So the private VI will be within that library. Only VIs in that library can use that VI. Yeah. So I don't know how many have used LabVIEW libraries. Yes. So it's a good way to organize code, to distribute responsibility of a code for application. So if you have multiple workers, one can work on one library or another can work on another library, and together they can form an application later on. And then you don't have your merge conflict on your project because they're using an independent library. See if I can find my what I have is a small demo, a couple of small demos, and a larger one later on. So a library is quite easy to make. New in a project, new library, and then you'll get a new library, and you can add all the files you want to do. So all the parts can be in the library. A project can contain multiple libraries. And you can also have a VI, I think I have a VI here, that can call without broken arrows, that can call the two VIs from each library. You can also see that the library as a VI is within the scope of the library. The name is not conflicted, even though they have the same name. And that is because these two VIs are in different libraries. If they are on their own within the project, you will get a conflict saying these VIs have the same name, you can't have them. Okay? That's a presentation. So yeah, multiple libraries. You can have one library. I can have another library with two VIs. You can have a VI that uses VIC, uses VIA from library A. I have seen this one also. Then VIB from library A uses VID. Don't do that. This creates a roundabout, and it will conflict later on when we talk about building the packed project libraries. that will be a mess. I also see people restricting, so some of the VIs are friends of another VIs and so on in these kind of roundabouts, and later on that will give a lot of headaches. Yeah, so and as for the name scope, that is what we're doing. So what we had before is that we had the name scope for VIA and the name scope for AVI for the two libraries that I had before. And that's why they can have the same name. Yeah, we have that test. If I go too fast, please let me know. So once you have a library, you could do one thing. You could actually build it. The best thing about building a library into a packed project library is that you are actually compiling the source code, and all the dependencies that this library needs is compacted into that packed project library. And that packed project library you can run directly. You could also use it on a co-worker's machine without having directly the dependency, unless you are using DLLs or something else. Then all that the VIs are needed are within that packed project library. And demo time again, if I can do that. So a build specification and LabVIEW slow, new packed library. Properties, you give them a name, you give them a description, and you specify where to build this project or this library into a packed project library. You specify which library should it be, and then you can build it. And hopefully, if I build, explore, and then I have my packed project library of library A, and then there's the one VI that we had before. But now it's can be run on a runtime system. Yep. I have to see. Yeah. So that's also very good. A nice little presentation. What happens if I have multiple deliverables? This is a small project. Also trying to see what can we do with the access scope of what should we remember also by the access scope. So I made 3 projects. Project A, B, so a library A, again, has its own packed project library. Library B has its own packed project library. And then I have an application that uses these 2 packed project libraries. The idea is that one library sets a value, and the other libraries should get the value. What most people do, if they don't use queues or any advanced features, they do it with global variables. So I have a global variable VI. That's just a numeric one. All of them is referring to the same global variable vi. So in theory, they should have access to the same global variable. So if I have my demo version, I have the two library calls, and then I also have the global variable out here. The first one, I can't see that. Oh, okay. Yeah. So the first one, library A, is just setting the global variable and getting out. That's just a glorified function global, but it's to demonstrate. Library B gets or reads. I can't do that. This one. It only reads the global variable. Quite simple. So if I run this, the only one that will actually have anything in there is the first one, and that is the one from the library A. The other two is 0. And that is because the scope, each of the variables or each of the libraries is compacting the global variable into themselves. So now the global variable is within the pack project library and in that scope. So now I officially have generated 3 global variables, 2 with 2 different scopes and the one from there. So they don't share the ones. That you have to remember that when you use that. Yep. You could, one thing was to put in one of the global variables into one of the libraries, and all of them use that global variable from that library. Yep. Does it make sense?
So in this case, it's better not to use them, right?
What?
It's better not to use global variables.
Yeah.
If you're involved, if you don't know exactly what is going on,
yeah.
It might be not better to.
But I have seen that that used, and people having doubts about why can't one library read the global variable. That's because of the scope of the VI. Yeah. So I have a small project. If I can get it up and running. These two. It doesn't like me. Try them. That's the part of the demo. So, what to do when you have a bigger application? And it might not work because I just worked on it, so it bear with me. Yeah, but the time constraint and Anders. Yeah. So if you are multiple teams of multiple persons, you can divide your task into different parts, and different parts can then be organized into libraries, and each library could then contain a module or an actor, if you know actor framework, do do its own thing. That could be reading for a DAC, that could be analyzing, it could be saving. So if you have that, you could have a source. Let's see that. You could have multiple modules, as we call it, each in their own actor, each developed by their own developer, but used commonly in their own in the same application. So we have a application that can run and load whatever pack project libraries is on disk and display them. So this one is quite simple. There's nothing that's on purpose. So I have made a module, a small GUI module. This one is a pack project library. We use it. It has a subpanel in it that can do this thing. And if I develop the application, someone else could develop the modules for me. Yes, I know what I'm doing. The module I have just added doesn't display into it, but it starts up the other module that I just added to the disk, and it's running by itself, and it can also exit the application. And all of them, of course, is on Git and shared. So if we just check this one. It relies heavily on other pack project libraries because the system, of course, in this kind of application has a lot of basic functionality for the system to handle and to work. And all these are built into, spread out to pack project libraries, because if I want to have non-redundancy, the circularized call stack, then I have to, all common features has to be within pack project libraries by themselves. This was the main UI we had before. And I can just see if I could add it to, I don't know. I could add whatever I like to it, and then I can rebuild that one, and it will display.
Maybe it was because it wasn't. How do you organize it in Git? Or coming to that?
Yeah.
It's
yeah. So one problem with a project like that is that if I want to build this module, if I don't set a settings that says exclude project libraries, LabVIEW, once I build this one, will move all the pack project libraries that is dependent on that this module is depending on, will move that with the newly built pack project libraries, and that can destroy my setup of folders on where I want to have my pack project libraries. So what you do is you click this, so it doesn't include all this, but then when you build it, it's very important that your target folder is aligned with all the other supporting pack project libraries that they have. So I built it into module libraries, but the other supporting libraries will always stay in system support libraries. And then I can commit this library with my built targets onto Git.
Yeah. But your dependency, are you copying it in manually when there's a new version, or are you having it as a submodule, or what are you?
They are part of the project itself. So often we deliver a system, so not updating all the time.
Yeah, but if you have a module you want to use in several projects,
most of the copy paste.
Okay.
Yeah.
Cool. Yeah.
You could. I haven't figured out. You can do some gets around externals. You could do that better in SVN.
Yeah, you can also actually make a submodule. If you make a Git repository inside a Git repository,
okay,
then you can have that as a separate, or you can add a Git repository inside it. So in a folder there is another Git repository, okay. And that one can be shared with other projects. So you can have one main, and then you have some different submodules. If you have different projects that are using same shared base of code, then you can do that. I can later on share, if we have time, or else you can call me afterward. But it's very simple to add that submodule in Git.
Yeah. You talked a little about. We talked about test time also.
Yeah.
A test time is kind of the same deal. If I like to organize like this, so I have a LabVIEW folder where all my test types source code is within. It has the same structure as the test time normally folder has. So in components, you have your step types, and in the step types, you can have your different development step types. So here I have a CAN driver that I use, and these are LabVIEW class within a pack project library. When I don't want to use them, I build them, and I build them into test stand components and step types again, and then in here it will be built into that one. Again, make sure then when you build dependency or dependent pack project libraries that you maintain the folder structure that you built to. Otherwise, it doesn't link dynamically these pack project libraries. It's kind of fixed within the pack project library. Which other pack project library do I depend on? And there's no way to tell a pack project library that you depend on something that is moved somewhere else. That's it. And one can also, you cannot in LabVIEW unload a pack project library. If you have loaded in something from a pack project library, it will stay into memory for the application or the development cycles.
When you close the project, does it unloads also?
Then it unloads.
Okay.
But you have to close it to get a new version of a built stuff. Yeah. Yep. I think that's more or less.
Yep.
Yes. A fast one. But,
yeah, very good, and it's yeah, definitely.
One thing that helped me with class-based sort of PPLs is I always put a who am I method in.
Yeah.
So that way you can track the version of the PPL, which leads on to automatically updating. If you've got this is a big distributed system, you can check the version.
Like a method, get a method that returns only the version. Right?
Yeah, essentially. Yeah.
Okay.
Yeah, the version. I mean, it returned other stuff. This particular one, but essentially, it's a describe yourself VI. It's quite useful for user interfaces if your hardware drivers describe themselves, because you can then do a dynamic user interface. For example. So it's a scope view. the who am I would bring back the ranges, for example. Use as a user interface. It's quite a useful thing.
One other thing also is quite good is to use the MDI's project solution builder. Then you can have a solution that can build all your dependencies in the right order and in a given version that you give. So if you have this kind of many pack product libraries you have to build at the same time, you can use that one to build them all in a new version. And that will build sequential, so it starts with the top one and it goes down from there.
Yep. Okay. I didn't know about that, so definitely.
Yeah.
Think about it. Yeah.
So this one is a copy paste from another project, so it's missing a lot of things, but I can just click build and it will build all of them.
Yep.
Yep.
Yes.
Any other questions? No?
Is there any problem that you had that you couldn't find out what was the issue?
One of the things is definitely linkage between pack project libraries or libraries that uses pack project libraries. There's some hiccups sometimes.
It's not easy to debug, I guess.
No, and suddenly it won't load, or it doesn't report that it's missing something, or it just don't want to load. Yeah.
Yeah. Yeah, I would say it's you can have success with pack project libraries, but there's a reason why NI, at least somebody in NI say that is maybe not optimal to, because you need to be sure about the linking and yeah. So
I would say pack project is quite good for when you have the structure.
Yeah.
But you have to maintain the structure.
Yeah. But libraries in the part there, that can help in what you talked about. If you divide different part up in different libraries, then the project will only store, say, you have this library, and then if one change a file via in one library and or add a file and another in another library, then you don't cause the VI to save.
The
project to save, yes.
Yeah, project doesn't know about the internals of the libraries, so you only know that it needs to add the library itself. So
I think there's a case also to match Git submodules up with libraries. You can have people working on libraries pulling into a project.
Yeah. That's
It's actually a fairly it matches as an architect.
Yeah. It's it can be complex if you have too many submodules. I have one customer who ended up having way too many, so they really cut down to like simplifying it, and then saying, okay, it's okay to have a little bigger Git repository and then different submodules. So I would try to tend to have my library small, but you can definitely do it, and it will make sense in the theory. But I think in normal way you will often have them have more libraries in one.
Yeah, I'm not saying
Yeah. No.
I would also say I've seen customers also having huge amount of VIs in a library and no structure in what this library has. So it also depends on your architecture of your deferring what does a library do, what does this library do, what does this library do. So you structure it in the right way. Otherwise, they can grow.
If there is no library, then the VI probably get in conflict soon, right?
Yeah. Or this cross call I have seen. I tried for a customer to build, but I figured out that there was too many cross links, so it was really struggling to just figure it out and clean up these libraries. And they have used French and they have used private VIs.
Oh,
cohesion is your friend.
Yeah. And if you build a library to a pack project library, don't have friends don't use that option. So in a library, we still have it.
What your friends over
there? I can set the access scope to this one, and I can set it to community, and I can tell who is friend of this library and who is then able to access the community scope VIs. But once we build this one into a pack project library, that one loses its functionality.
Yeah, because each pack project library is like its own instance.
Yeah.
And when you are in the development system, you can like see everything.
Yeah.
But when you are in a pack project, it's only that instance. It's another instance, so you can't share in that way.
Yeah.
It was the one you had with a global file.
That's the same with the global.
Exactly,
Global files.
I think, full disclosure with me, I went down the route of pack project library from big project, and I was warned.
Yeah.
And I said, no, this is brilliant, and it all worked brilliant the first time I did it, and then it started to get a bit cumbersome to maintain. I got a bit annoyed.
Yeah.
And then it went wrong, and that was it. I was out. Then I undid it all. Went back to normal.
So I would say it's good to have access scope for public and private. Private can do that. You limited your interfaces to this pack project library, and so if you hand out the pack project library to your coworker, they know exactly only the interfaces that they can use, and all other things are hidden behind.
When you compile the private ones, they are not showing.
They're not shown.
Okay.
Yeah. So you limit the list of VIs they can use.
Yeah. Okay.
It's a good way of protecting your IP as well.
Yeah.
That's the other good thing.
Yeah.
It's